Suppose we roll a pair of dice, and these are your total 36 outcomes. And the way you read them is like, for example, this 4 1, this refers to your die 1, you got 4, and your die 2, you got 1. What is the probability that either the first number is even or your second number is odd? These types of questions are answered by addition rule. This session is about addition rule. By the way, the answer for this is 75%. So let's review the definition of probability real quick. So the probability of an event E is defined by this expression. It is equal to the number of favorable outcomes divided by the total number of possible outcomes. If omega is your sample space and E is a subset of omega, then the probability of E is given by the size of your event E divided by the size of your sample space. Let's understand this through a simple example. Let's say in a two-coin toss, the question is, what is the probability of getting both heads? Well, here my sample space is head, 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 tail, tail, tail. Right here. Okay, these are my samples elements in my sample space, and my size of my sample space in this case is 4. The event E in this case is that both tosses are head. There's only one element over here, head, head, which is this right here. So my size of my E in this case is 1. So the probability of E is going to be 1 over 4. I'm just using this expression right here. Now let's take a look at some of the important properties of your probability. I'll be using die example. The first one says that the probability of any event E is between 0 and 1. So for example, when you roll a die, probability of getting even number is 3 over 6 because there are 3 even numbers. Probability of getting 5 is equal to 1 over 6 because there is only one 5. Probability of getting 9 is 0 because there is no 9 in the when you roll a die. This one says probability of your sum of probabilities of sample space is equal to 1. So for example, if this is your sample space, when you roll a die, in this case, your probability of your sample space is going to be the probability of your 1, which is 1 over 6, plus probability of getting 2, which is 1 over 6, plus probability of getting 3, which is 1 over 6. And you just add them all together, and the answer will always be come out to be 1. This one says that the probability of an event that is not in your sample space is 0. So for example, probability of getting 8 when you roll a die is equal to 0 because 8 is not part of your sample space. This one says the probability of getting not E is equal to 1 minus probability of E. This right here, some authors, they use this notation. They write E bar, some authors, they write E. C over there, which stands for complementary rule. Some authors, they write E and then they put a little tilde in front of it. So for example, probability of not getting 4 is equal to 1 minus probability of getting 4, which is equal to 1 minus 1 over 6, which is 5 over 6. This is a kind of helpful rule. Sometimes it's not easy to find this one directly. So you may know the answer for this, or this may be easy to solve. And from there, you actually solve this one. Now, two events are mutually exclusive events or disjoint even if they cannot happen at the same time. In other words, they have no outcomes in common. If A and B are two disjoint events, then we denote them as A and B equal to null. Now, this right here, it's referred to as a null set or empty set. Another way of rewriting this is A intersection B equal to null set. You can also represent this through a Venn diagram. So this is my sample space, contains everything in it, and my A and B, let's say denoted like, draw a diagram like this that denotes my A and B. So in this case, you can see that A and B are disjoint. In this particular instance right here, this is my sample space, and my A and B, they are not disjoint. They do have some elements in common. Okay, so let's understand this through some examples. Let's take a look at example of disjoint event first. So let's say your event A is defined as rolling a die and you're getting an odd number. So you can get 1, 3, 5. All right, and your B is rolling a die and getting an even number. So in this case, you can get 2, 4, and 6. And you can see that A and B have no elements in common. So A intersection B is a null set. Let's take a look at this example. A is randomly selecting a person with a type A blood. So these are set of all people who have a type A blood. And event B is randomly selecting a person who has a type O blood. So in this case, these are set of all people who contains type O. And clearly, A intersection B in this case is a null set because you cannot have people who have type A and type O blood at the same time. Let's take a look at this example. Examples of non-disjoint event. A, rolling a die and getting an odd number, 135, and rolling a die, getting an even number, getting a number that is less than 3. So in this case, you can see your 1 is a common element right here. So if you represent this through a Venn diagram, this would be like 3 over here, this would be 5, and your 1 is a common element. And for B, you're going to have 2 right here. So B has 1 and 2. This is my B, and my A is 135 right here. And you can see that your 1 is a common element over here. So A intersection B is 1. In this example, you randomly selecting a person with the type A blood. So these are people with the type A blood. And then you have B, randomly selecting a person with gender as a male. And these are the people who have gender as a male. And you can see that in this case, your A intersection B is going to be set of all males who have a type A blood. So this would be this people right here, a finite set. So this is the general addition rule. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B right here. Another way you can rewrite the same expression is this small notation. You can say probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. In this case, what's happening is that let's say this is my A event right there, this is my B event, and this thing is common intersection. And now this common intersection actually is getting added twice, one from A and one from B. So that's why you're removing one of them. So by doing this right here, minus this expression, you're removing the effect of one of these elements. Okay, a special case. So if your A and B are disjoint, so like coming down to this case, my A and B, they have no element in common, then my probability of A intersection B equal to 0. In other words, this one right here, this is going to become equal to 0. In that case, my probability of A union B becomes probability of A plus probability of B. Suppose you randomly select a whole number between 1 and 13. So what is the probability that it is a multiple of 2 or multiple of 3? In this case, my sample space is given by numbers from 1 all the way up to 13. So let A be an event, randomly selecting a whole number between 1 and 13 that is a multiple of 2. So my A would be given by these set right there, 2, 4, 6, 8, 10, 12. I'm representing this through a Venn diagram. So these are my A elements right here, from here all the way up to here. Okay, then you have B, which is randomly selecting a whole number between 1 and 13 that is a multiple of 3. So B would be 3, 6, 9, 12, and I'm representing my B through this Venn diagram right here. So these are my elements in B. Now, here I have to find probability of A union B, and we know the formula for that. The formula is given by this expression right here. Okay, in order to solve that, I need to know my probability of A, I need to know probability of B, and I need to know probability of A intersection B. So let's focus on A intersection B first. So A intersection B is the numbers that are multiple of 2 and 3. In this case, A intersection B would be 6 and 12. These are the only two numbers. You can see that 6 is over here and 6 is over here. 12 is over here, 12 is over here. You can also see this from Venn diagram. So this element right here, these ones, 6 and 12, these are common to A and B. So here my probability of A would be 6 over 13 because there are 6 elements in here. Let me just remove everything. So this one actually has 6 elements. This one has 4 elements. So probability of A would be 6 over 13 because there are 13 elements in your sample space. Probability of B would be 4 over 13 because there are 4 elements in samples in event B. And probability of A intersection would be 2 over 13 because there are 2 elements over here. You can count that. It's only 2 elements. Okay, putting this in the formula, substitute your values for PA, PB, and PA intersection B, solve the expression, your answer is 0.615. So that's the answer, the probability that your number is a multiple of 2 or multiple of 3. So suppose you randomly select a whole number between 1 and 13. So what is the probability that it is an even number less than 9 or an odd number more than 6? So the sample space in this case is given by 1, 2, 3 all the way up to 13. So let A be an event, randomly selecting an even number that is less than 9. So my A would be given by 2, 4, 6, 8 right here. Okay, so my A in this case, I'm just representing that through a Venn diagram. So these are my elements of your A. Same thing with your B, randomly selecting an odd number that is more than 6. So in this case, my B would be 7, 9, 11, 13, and I'm representing my B again through a Venn diagram. Okay, so to do these types of question, you have to find your probability of A union B. So this is the equation, this is the formula that I'll be using. Okay, and let me just remove everything. Okay, so let's focus on A intersection B first. My A intersection B is a null set. Another name for that is an empty set. There's nothing common between A and B. You can verify that from your Venn diagram, and also you can verify that by looking at this. There's no common element between A and B. And then so the probability of A would be the number of elements in A divided by total number of elements in your sample space. Well, number of elements in my A is 4. And how many elements I got over here? 4. How many I got over here total? 13. So probability of A is 4 over 13. Probability of B is 4 over 13 because there are 4 elements in B. Probability of A intersection B is 0 because A intersection B has no elements. The number of elements over here is 0. So I'm using my formula right here, probability of A or B, and put in your numbers, PA, PB, and PA intersection B, and your answer will come out to be 8 over 30. So suppose we roll a pair of dice. What is the probability that the sum of two dice is 7 or that the number on the first die is 4? So the sample space in this case is given by this diagram right here. So this axis right here represents my outcome of my die 1, and this one represents my outcome of my die 2. Total 36 elements in total when you roll the pair of dice. So the way you read this is, let's look at this number 2, 2 comma 3. This basically means that your die 1, you got 2, and on die 2, you got 3 over here. So that's what 2 comma 3 means. So let A be the sum of two dice is 7. Let me remove everything. So my even days sum of two dice is 7. That would be these elements right here. You can see that you add all the numbers over here and the answer would be 7. Write these elements. Okay. So the my event B would be the number on the first die is 4. Well, that would be this right here. You can see that on this set of elements, your number on the first die is 4. So here I have to find a probability of A or B, which is given by this expression right here. So let's focus on A intersection B. That would be the sum of two dice is 7 and the number on the first die is 4. You can take a look at this diagram right here and you can see that this element right here, 4, 3, that is your intersecting element, okay? 4, 3. So there's only one over here. There's only one number of element. Okay, so the probability of A would be 6 over 36 because the count for your A in this case is 6. There are total 6 elements. Your count for B in this case is 6. There are total 6 elements. You can also count over here, like how many elements you got over here. This is 6 elements, and over here you got 6 elements. Okay, so it's going to be 6 over 36. Probability of B would be 6 over 36 again. Probability of A intersection B would be 1 over 36. 1 because there is only one element in A intersection B. All right, so I'm using my formulas. Substitute your numbers, and your answer would be 11 over 36. So suppose we roll a pair of dice. What is the probability that either the first number is even or your second number is odd? So in this case, my sample space is denoted by these numbers right here. This is my die 1, numbers corresponding to die 1. These are my numbers corresponding to die 2. So let A, the first number is even. This is your event A. So in this case, my first number is even. That would be all these numbers right here. This one, the whole thing right here, okay. Then this one right here, this whole set of numbers, and these numbers, the whole set of numbers. In this case, your first number is even. You can see that. So let me remove this. So I drew this over here for convenience. You can see my A is given by this right here with yellow highlighter. So there are like A over here, A over here, A over here. All right. In this case, A will have 18 elements total. You can see that this one actually has 6 elements over here, then you have 6 over here, and then you have 6 over here. So 6 plus 6 plus 6 is 18. Okay, now let's focus on the B. The second number is odd. So in that case, my second number is odd would be these elements right here. All these elements, this one, and these ones all the way to the down, all the way going down, and these elements. So in this case, I drew this diagram over here. This is my B. And in this case, all these elements right here, this is my elements of B. And you can see how many elements I got. I got 6 over here, I got 6, and I got 6. Total 18. So B actually has 18 elements in total. Okay. So in this case, I have to use a probability of A or B, which is given by this expression. So let's focus on A intersection B first. So the number of elements in A intersection B is the number of elements that where the first number is even and the second number is odd. You can see that A intersection B are these elements right here. This one, this one, this one, this one, this one, this one, and this one, this one, and this one. So these are numbers. They are basically common to both A and B. And the numbers in total will be 9. There are total 9 elements. Okay, so my probability of A is 18 over 36 because there are 18 elements in A. I just showed you. Probability of B is 18 over 36 because there are 18 elements in B. And the probability of A intersection B would be 9 over 36 because there are 9 elements in A intersection B. So using your formula for your A or B, I'm just substituting the numbers and my answer comes out to be 3 over 4, which is 75% chance. So a square dartboard has corners given by these coordinates 0, 0, 0, 10, 10, 0, 10, 10. These ones right here. This one, this one, this one, and this one. So a dart is thrown randomly at the board such that every point on the board is equally likely to be hit. Define following two events. Event A, that the dart lands to the left of the vertical line x equal to 6. So this is my x equal to 6, and my event A would be that the dart lands on this side of the area, on this side right here. So this whole region, dart landing in this place, that is my event A. Okay, my event B would be that the dart lands below the horizontal line y equal to 7. So my y equal to 7 is this right here. And the dart lands below that. In other words, in this region right here. So this is my event B right here. Okay, so using the addition rules of probability, compute the probability that the dart lands either to the left of the line x equal to 6 or below the line y equal to 7. So you have to determine whether the probability that the dart lands in this side, right, below this, or towards the left side of this right here. That's what you have to find out. Okay, assume that the probability is proportional to the area. Here, we have to find probability of A union B, A or B using addition rule. We also are given that the probability is proportional to the area. So event A would refer to that your dart lands on the left-hand side, your x equal to 6. In other words, the dart lands over here. All right. So in this case, my probability of A would be this area, right? This area. In this case, this area would be 6 over here. This is my 6. And the length from here to here is 10. So 6 times 10. This is my area for my event A divided by the total the area of your sample space, which would be this from here to here is 10. So it's going to be 10 by 10, and the answer comes out to be 0.6. Same thing, probability of B now. So your B in this case would be defined by y less than 7. Your y less than 7 would this part right here. Okay, and you calculate the area of this, and the area is 7 times 10, and divide by 10 by 10. 10 by 10 is your size of your sample space, and the answer comes out to be 0.7. Okay, so I know my probability of A and I know my probability of B. Now, let's calculate the probability of A intersection B. So you need A intersection B first. So your A intersection B would be x is less than 7 and y is less than 7. That would be this region right here. From here, this would be your this region, okay? And then the other one would be this region right here. So intersection of these regions is this part right here. So this is the intersection of A and B. So let me remove everything and let me just draw this line right here. So this is my A intersection B, where both my A and B are overlapping. And what is the area of this? This is 6 times 7. So 6 times 7 divided by 10 by 10 is 0.42. So I know my probability of A intersection B. So using your regular formula, your answer would be 0.88.